Hello students, myself Keval Patel, Assistant Professor from LGIT. So students, in the last lecture, we have to discuss about how to select a section for gantry gutter. But there are lots of doubts from student side of view. So let us revise in which type of section we have to decide for exam point of view. So students, this is our question that design a gantry girder for the following data in which there are two types of span is given. So your first span is crane girder span which is given as 15 meter, and second one is gantry girder span which is given as 7.5 meter. Okay, so in the first step we have to find out maximum wheel load. So you can see that there are two wheels which is moving on each of the gantry girders. Okay, so first of all, in the first step we have to transfer the load from crane girder to gantry girder. Okay, so whenever we have to transfer a load from crane girder to gantry girder, there are main four types of load which we have already discussed. So it is your first load is vertical loads, and in vertical loads you have to consider three major loads. First one is crane girders load, second one is trolley. It means you can see that this is your crane girders load, second one is trolleys, and third one is hook load. And in hook load you have to consider as the maximum load which is lifted by the hook, and this load is called as the crane capacity. Okay, so this is your vertical load, second one is impact load, third load is a surge load, and at last fourth load is braking load. Okay, so students, in the step number one we have to find out maximum wheel load. It means your per wheel load which is transferred from crane girder to gantry girder, and on gantry girder there are two wheels. So one wheel takes a reaction of 300.75 kilonewton. In the second step, we have to find out maximum bending moment which is generated in the gantry girder. So students, it is already discussed that in this step we have to use absolute bending moment, and in absolute bending moment we have to consider one statement that the maximum bending moment will generated on a span of capital B by 4 from the center of the span. Now, what is capital B by 4? Capital B means the width or width of wheelbase. Okay, so it is given as 3.5 meter in the question. So our maximum bending moment which is generated on a gantry girder is 681.85 kilonewton into meter. Okay, and in the third step we have to find out maximum shear force which is generated in gantry girder. So in maximum shear force which is generated in gantry girder, it means whenever this is your crane girder having a span of 7.5 meter. Now you all know that your crane is moving like this, and when your crane is stop at either end of the gantry girder, that means it is the maximum shear force at that point, and this value is find out as 471.83. Okay, so students, this is a revision of our step number 1, 2 and 3. Now we are moving further to our step number 4, which is section selection. So students, it is already discussed that there are lots of section selections are there for your exam point of view, but for practical point of view we have to consider I plus C, and the reason behind this I plus C is already discussed that the I sections means your I beam, I girder is restrains only vertical loads and vertical moments, but there are another load which is acting on this direction. This direction is your axial direction, and when your trolley is moving like this and stop at one place, then this type of force is acting on the gantry girder. Okay, That's why we have to resist the horizontal force. We have to put down our C channel section on the top of the I girder. Okay. Now, whenever we have to select for I section, there are main two criteria are there. First one is economical depth of girder. Okay, so the range of economical depth of girder is L by 15 to L by 12. Okay, in your book it is clearly mentioned that it is L by 12 but not compulsory to take L by 12 all times. Okay, it is in the range of L by 15 to L by 12. Now you have to design for gantry girder. So the span of gantry girder in your question is given as 7.5 meter. Now 7.5 meter it means 7500 mm. So your 7500 mm divided by 12. So your answer is 625 mm. But if you are see that in your steel table the maximum depth of section, this is your rolled section and the meaning of rolled section is the ready-made section which is available in the market. So so the ready-made sections depth is maximum 600 mm in your steel table. Greater than 600 mm thickness section is not available in the market. Okay, if your depth required is greater than 600 mm, then you have to made up or you have to give some order for that section, and this section is will be discussed in our next chapter. It is considered as a plate girder. Okay, your next chapter is design of plate girder in which there is a long span, and when your span is long then the bending moment is also increased, and if your bending moment is there heavy then you have to take higher depth of section to resist that moment. Okay, so students, let us start our step number 4, which is the section selection. And in section selection step, our maximum depth of girder is 600 mm. Now, second is width of flange. Okay, so this is the width of flange, and the range of width of flange is L by 40 to L by 30. Again, if your span of gantry girder is 7.5 meter, then L by 40 to L by 30, it is 187.5 mm to 250 mm. Okay, so students, you have to choose your section in such a way that your maximum depth of girder is 600 mm or less than 600 mm, and your width of flange is in the range of 187.5 mm to 250 mm. Okay, so in this example we have to choose ISMB 600 with a channel ISMC 300 mm. Now, these both the properties is directly coming from steel table. So you all the students are moved to steel table in which we have to choose ISMB 600. It is not compulsory to you all that you have to choose ISMB 600 only. You can also choose ISWB 600. Okay, ISWB 575, ISWB 550, but this is trial and error method. So we have to try in our exam point of view for higher section, and our higher section in steel table is ISWB 600 with a channel ISMC 300. But for channel point of view, your heaviest section is ISMC 400. But in this example, we have to choose ISMC 300. So students, this both the properties of selected section is directly coming from steel table. Now you all know that your I section is symmetrical section, and for symmetrical section your CG is exactly at the center of the section. Now if you have to provide it channel section on the top of the flange, then obviously your CG is moving on upward direction, and in the last lecture we have to discuss that our section of the combined and the CG is moving on the upward direction with the distance of 64.21 mm, because if you are selected only I section having the depth of 600 mm. Then what is the CG of 600 mm? It is 300 mm. But whenever you have to provide it channel section on the top of the flange, then your CG is moving on the upward direction and it is final answer is 364.21 mm. Now we have to find out the moment of inertia of this combined section. Okay, so let us start our moment of inertia calculation, in which the equation Izz is equal to Ixx1 plus Ixx2. Now Ixx or Izz1, it means we have to choose our I section is our section number 1 and channel section is section number 2. Now the equation is remains same, Ig plus Ah square for both the section. Now Ig means moment of inertia in x direction, because we are discussing about Ixx or Izz. Okay. Now you can see that Ixx, it means our first section is I section. So you can see that for I section your Ig is 91813 into 10 raised to 4 plus A means sectional area. So the sectional area of our I section is 15621. So it is 15621 into h square. Now what is h square? Okay, so h square means the CG of combined section, it is 364.21, and CG of your first section, which is 300 mm. So the difference between 364.21 minus 300 is called as h. So in this term it is h square, so it is 64.21 square plus. Similarly, for second section, it is Ig plus H square. But in the steel table, these two property is given for vertical C section. So it is like this. This is your C section. But we have to provide it this channel section in a horizontal side. Okay, not on a vertical side. So for this section, our Ixx became Iyy and our Iyy become Ixx. Okay, so our Ixx, it means our Iyy in this example it is 310.8 into 10 raised to 4 plus A means area of second member into h square. Okay, so h square is remain same, it is the combined sections CG minus second member CG square, so it is like this. So students, our Ixx for combined section it is 1206.11 into 10 raised to 6 mm raised to 4. Similar calculation for Iyy, it is Iyy1 plus Iyy2. So all the equations and all the calculations remain same. But the only change is you can see that whenever you have to cut your section from y-axis, then if this is your y-axis cut and you can see that this is your mirror image. Okay, and when your mirror image is there, your h value is equal to 0. It means your Iyy is equal to Ig1 plus Ig2. So your combined answer is 9013.6 into 10 raised to 6 mm raised to 4. Okay. So students, this is our provided sections figure, in which you can see that this is I section and on the top of the flange you have to provide it one channel section is there. Okay. So students, this is the end of our step number 5, and the last calculation is ZE or ZP. Now what is ZE? ZE means elastic modulus. So for elastic modulus, your answer equation is Izz divided by y maximum. Okay, so it is 1206.11 into 10 raised to 6 divided by 364.21, and you will get your answer 3.31 into 10 raised to 6 mm cube. Okay, so students, this is the end of our step number 5. Now, in the next lecture, we are discussing about our selected section is pass or fail. So, if you are checked for moment capacity, for shear capacity, and for buckling capacity, and for this all this check, your maximum answer or your selected section answer is greater than the required section's answer, then your selected section is pass. Otherwise, you have to redesign the section. Okay. So students, in the next lecture, we will discuss about our selected section is pass or fail. Okay. So students, this is the end of today's session.